For 1,000 years, one star has been keeping a secret. Betelgeuse, the red giant on the shoulder of Orion, pulses brighter and dimmer on a rhythm nobody could explain. In 2019, the whole world thought it was about to explode. It wasn't. The truth turned out to be far stranger. Something has been hiding inside Betelgeuse this entire time. And when astronomers finally photographed it, it was nothing like what they predicted. This orange-red supergiant, catalogued as Alpha Orionis, marks the right shoulder of the familiar Hunter constellation. Visible to the naked eye as one of the brightest objects in the night sky, Betelgeuse is a cosmic monster. If placed at the center of our solar system, its vast perimeter would swallow Mercury, Venus, Earth, and Mars, spanning a width roughly 700 times greater than our Sun. Yet, despite its swollen, dying state, Betelgeuse is remarkably young, only about 10 million years old. Massive stars like this burn through their thermonuclear fuel at a furious pace, rushing toward their end in a fraction of the time of smaller stars. For centuries, astronomers observed this giant, lying roughly 600 light-years from Earth, assuming it was a solitary colossus. Generations of observers mapped its shifting light, identifying a familiar 400-day cycle. This is the giant's natural breathing rhythm, a physical expansion and contraction of its outer envelope as heat escapes from the core. But beneath this rapid pulse lies a second, far slower clock, a distinct brightness cycle lasting about 2,170 days. For generations, this 6-year rhythm baffled observers. In stellar physics, a single star can easily pulsate on one frequency, but sustaining two entirely separate, highly precise rhythms is a mechanical paradox. A dying supergiant is a chaotic cauldron of boiling gas, making its steady precision highly unusual. What could possibly impose such a steady, long-term rhythm on a star that was supposed to be completely alone? In late 2019, the star's visible light plummeted. By February 2020, Betelgeuse had lost over 60% of its normal brightness, sinking to its faintest level in 2 centuries. This sudden collapse triggered global speculation that the supergiant was about to explode as a supernova. But a true core collapse behaves far more violently than a temporary dip in brightness. By 2023, high-resolution infrared and interferometric data from the Very Large Telescope revealed the true cause. Betelgeuse had expelled a massive bubble of hot gas from its surface. As this material drifted outward, it cooled into a dense cloud of dust, physically blocking the star's light along our line of sight. The dust eventually dispersed, allowing the giant to recover its full luster. The 6-year mystery remained completely unexplained. Archival photometry contains subtle, repeating irregularities in Betelgeuse's position and motion. Slight wobbles in astrometric measurements, combined with variations in radial velocity, with the giant periodically shifting toward and away from Earth, suggested a gravitational tug. An unseen companion in a repeating orbit could explain this pull, acting as a physical partner that influences the outer envelope. Other explanations remained. Giant convection cells boiling on the surface, or unusual, unmapped pulsation modes could also mimic these patterns. To isolate the truth, astronomers needed direct imaging, but early attempts failed. Space telescopes like Hubble and Chandra scanned the surrounding space and found nothing. Against the overwhelming glare of the supergiant, however, an inconclusive non-detection was far from proof of absence. The companion remained entirely lost in the light. Orbital calculations soon revealed a narrow window. In early December 2024, the projected path of the suspected companion reached its maximum distance from the giant star. This was not a large physical gap, but a favorable viewing angle, placing the hidden source at an estimated separation of just 50 milliseconds. This tiny angle, far below ordinary visual resolution, represented the only chance to glimpse the object before it slipped back into the blinding stellar glare. If astronomers missed this brief alignment, the next window would not open for another 2 years. Telescope schedulers faced a compressed countdown, leaving researchers to wonder if the tiny, hidden source could be isolated from the glare at all. On December 9, 2024, astronomers pointed the Gemini North telescope in Hawaii toward the supergiant. Instead of space-based assets, researchers utilized Alupeke, a ground-based speckle imager. By combining thousands of ultra-short, 10-millisecond exposures to freeze atmospheric distortion, the instrument captured a faint blue-white point of light. Located just 52 milliseconds from the giant, this signal was roughly 6 magnitudes fainter than its host, representing a flux ratio of just 1 to 250. Led by Steve Howell of NASA's Ames Research Center, the team announced this probable direct imaging detection in July 2025, informally naming the companion Betel-buddy. Astronomers initially expected to find a dead stellar remnant, such as a white dwarf or a neutron star. However, an October 2025 Chandra X-ray analysis led by Anna O'Grady of Carnegie Mellon University detected no high-energy accretion signatures. Instead, soft thermal emission pointed to a hot star of about 1.5 solar masses. This companion is in a pre-main sequence phase, having not yet begun core hydrogen fusion. The two stars were born together, yet they occupy opposite extremes of stellar evolution. While researchers require follow-up observations to confirm the orbit, this finding alters our understanding of dying supergiants. Subscribe and turn on notifications to follow this stellar mystery as astronomers prepare for the companion's return in 2027. Astrophysicists calculate the companion's projected orbit at roughly 4 astronomical units, equivalent to 4 times the distance from Earth to our Sun. At this scale, the smaller star does not travel through empty space. Instead, it moves directly through the bloated outer layers of Betelgeuse's atmosphere, which extends far beyond the star's visible boundary. It represents the first companion ever discovered operating well inside the envelope of a red giant. As the star pushes through this thick outflow of material, it leaves a trailing wake in its path. This physical interaction sweeps and redistributes the obscuring dust clouds that naturally gather around the dying giant. Researchers suspect this periodic clearing acts as a cosmic snowplow, lifting the dust veil once per orbit to drive the long 6-year brightness cycle. While this model requires further orbital data to confirm, it directly connects the system's strange geometry to its oldest unsolved mystery. Moving directly through this dense gas, the secondary star experiences relentless physical drag. This resistance steadily drains its orbital energy, initiating a slow inward spiral. Models predict this friction will eventually cause the companion to plunge entirely into the giant's expanding outer envelope, with an estimated submergence timescale of roughly 10,000 years. This system represents an extreme mass ratio binary, where the primary's immense glare almost completely drowns out its lopsided partner. This vast disparity in mass and brightness makes such systems exceptionally difficult to find and study. While the predicted engulfment remains a distant, long-term projection, a much closer test awaits. In November 2027, the companion will reach its next predicted maximum separation. This upcoming window serves as a checkpoint, allowing astronomers to track its orbital motion, and prove the two stars are truly bound. Finding a young star nested inside a dying supergiant's envelope forces a complete rewrite of how massive stars evolve. If confirmed, Betelgeuse is no longer an isolated colossus, but an interacting binary system. This shifts our understanding of stellar mass loss, showing how a companion can sculpt dust winds from the inside out. While this offers an elegant solution to a centuries-old brightness riddle, researchers still require definitive orbital tracking before the discovery is fully settled. This cosmic relationship will ultimately end in engulfment, a quiet merger that remains entirely separate from Betelgeuse's eventual violent supernova. The final proof waits for the next return. We now see Betelgeuse not as a solitary giant, but an active, devouring binary. As this young companion spirals toward its inevitable engulfment, it completely rewrites how massive stars die. The clock is ticking toward the 2027 alignment, when the universe will deliver its final, undeniable proof.